All right, I'm going to go ahead and get started. And when I present, I wander, so I'll warn you now. Hopefully, I won't trip over anything. Um, so my name is Jenni Syed. I am a principal engineer at Cerner. I am responsible for our FHIR server that we've implemented. To give an idea of how long I've been doing this, we started working on beta implementations of FHIR in 2014 against DST1 at the time. And our first server went live in production in early 2015 on the May ballot for DST2. And now we have the final version out, so we have DST2's version of our FHIR server out, and we're getting ready to obviously move on to more. So a lot of what I'm going to talk about today are common mistakes and kind of hints to help people that are developing apps both troubleshoot and avoid mistakes based on what we've seen on all the different apps that have come through our store. What I will talk about today, there's a few places where I'll hint at how to do stuff maybe on the Cerner implementation, but most of what I'm going to talk about is not specific to Cerner. It is best practices just for Smart, for FHIR, and OAuth. Okay? Out of curiosity, how many people in here have already written a Smart app or an app using a FHIR server or a FHIR client? Okay, so I'm going to assume most of you are just thinking about it, so you're trying to get ahead of the game. It's a good idea. Okay, so to get started, some of the first things I'm going to talk about is when you are first developing and you start running into issues, some of the things to keep in mind as do's and don'ts as you're working through developing an application. And I'm calling these out first because they can be pretty important. So do try to recreate it in whatever public sandbox you're in, right? It helps. Try to figure out what's going on if you can recreate it. In our server specifically, we return an X request ID or a correlation ID so that if you reach your wit's end, you can give us on our help channel this and we can track down exactly what happened. Do whichever FHIR server you're looking at, try to look at the response and see if there's an error message. Most servers return something. In some client libraries, it may not be as easy to find this, so you may also need to figure out for your client library or for your browser's development tools how to look at the response. And do double check the documentation. I do not want to use RTFM. That's not what I mean. I do not expect you to read the full spec or everything, but when you start to run into issues, it's really good to go double check your assumptions and look at documentation specific to what you're trying to do. And definitely use your debugging tools if you have them, because those will help you a great deal. Things not to do. When you are doing this, do not compromise PII or PHI. Right? You are working in systems that have actual patient data. Don't go to a public group and post somebody's patient data. Like, that's not a good idea. Do not compromise secrets. So again, if you're having troubles with OAuth, don't post your bearer token to a public endpoint. Somebody can literally take that and now act on behalf of your app and do nefarious things. Don't ignore errors. So if you see something and it seems like a fluke and you can't reproduce it, that doesn't mean that it's not a problem. It may mean that it's just harder to reproduce, so don't ignore it. And again, with that, don't assume it was a fluke. Sometimes edge cases surprise you with how very, very edge they can be. And then, of course, the next thing, which we kind of hinted on, is know where to find your documentation. FHIR is based on REST, which is based on HTTP. A lot of times knowing the HTTP spec, or at least how to look up things, is very helpful. So knowing where to go find it is great. These slides, I believe, are going to get released if you can't do it. Can't find them easily. Beyond the HTTP spec, so REST is based on a lot of different extensions to HTTP that include special errors, and a lot of these are used in FHIR. If you're really curious what the heck a certain error means and you can't find doc, Wikipedia actually has a really good list of them. You can always also go find them in the different extensions. So like WebDAV specifically has a couple. So that 422 unprocessable entity is one that we see a lot in FHIR, and it's a good one that you could go find and see, like, it's basically telling you, I understood your request, I didn't know what to do it, and we'll get into this a little bit more. And then, of course, know where to find the FHIR specification. In this case, it takes a lot of what HTTP is and calls out specific errors and success codes that are supposed to come back from a FHIR server if somebody implements it correctly. I will say this table is gross. There's actually better information on each different action in the FHIR specification. This was just a good overview to call out that FHIR does call out what statuses are supposed to come back on requests. And then for Cerner specifically, but this is true for most FHIR servers I know, they will have their own documentation. So know with the implementation you're looking at where to find documentation. So for example, this is Millennium's implementation, and it talks about common client errors on our overview page, as well as on each resource we'll call out specific errors that might be returned in that resource only for special use cases. So another thing that is becoming more and more used and is really important to understand if you're trying to figure out and troubleshoot your application and errors that are coming back from a server is to understand the operation outcome. And I will say it was not used very much by most servers except for reference servers in the beginning. So what the heck is an operation outcome? In FHIR, it is its own resource. Just like allergy intolerance, operation outcome is its own thing. It's defined in the specification. Like I said, it has limited use currently, but its whole intention is to give you additional information about what happened in the server, and it actually can come back both on success and on failure. So there are different levels on the operation outcome. It can say that it's fatal, so you probably got an error back from the server in this case. Informational, to just say that, hey, I took your request in, but maybe something in there went a little funky and I want to let you know. So for example, I couldn't translate this code, so it's free text. An example from one of our servers, and this is, you can see it's a fatal severity. So this is an example of what would come back from our server if something really bad was going on behind the scenes. In this case, the error that comes back is 500, and it tells you that something is really weird because the documentation, the resource behind the scenes is missing its status, which clinically is a bad thing, and it also violates to spec to not have a status, so we error out and then include that so that we can go figure out what the heck happened. Usually for us, this is a terminology mapping issue. All right, so you know where all your documentation is now. You know where the HTTP spec is, you know where the documentation for HL7 is. The next set of errors that we see most commonly, I will say that this happens a lot within restricted VPNs especially, are connection issues. And usually the request we get is, your FHIR server's down, it's not responding. Or I can't contact the authorization server. Or my own app can't be launched. You guys aren't calling me or something like that. So the most common problem we see with connection issues are firewalls. Healthcare, right? We like to make sure that there's limited access into the healthcare network. This especially happens during your initial install. It's usually something that once you've fixed it, hopefully it doesn't come back, but that's not true depending on the security at this specific site. This can be a connection to your application, but it can also be a connection to OAuth Smarter FHIR that can go wrong. To narrow down connections, and I'm going to try to limit this to basic tooling that's available everywhere, so I'm not going to jump into Wireshark for those of you that are really, really used to troubleshooting connection issues, because first of all, most people won't let you install Wireshark on their networks. So the easiest thing for FHIR or for OAuth is to load a URL in the browser on the device that's having issues and see what happens. For FHIR, the metadata endpoint can't be secured. Like, you can't do that, it wouldn't work, because that's how you figure out where OAuth is. You can use the metadata endpoint in a browser to see what happens and to see if the browser can contact that, and that'll eliminate code issues. Ping is your friend, and it can be more useful than maybe you're familiar with. So ping can both tell you if it can connect, as well as, is it only me? So try out ping on a couple different devices and see what happens. And then the other thing that you'll notice from ping that a lot of people may not think about if you've never had to use it besides just seeing if you can resolve something, is in this case up here, I can tell that it's not a DNS issue because I can see that it found the IP address. So I can see that at least it recognizes the URL I'm hitting. However, I'm seeing a whole bunch of timeouts. So in this issue above, to me, this is a firewall issue. There's something that's probably eating your request. And that's where I would usually start to go. Another really useful tool that's available by default mostly is OpenSSL. But we'll get to that in a little bit because there's a lot more to OpenSSL. The next most common issue we see, especially for people that have not done TLS or secure browser deployments or secure deployments before, is that certificates can sometimes, especially for example in Java, can look like connection issues. They can look like there's something wrong. The most important thing to debug certificates is to know your stack. So if you're using Java, understand how to troubleshoot issues and connections in Java. And then in addition, every programming language that I know and every operating system that I know has a trust store. And if somebody is using a certificate that's not one of the big certificates, or somebody is on a much more locked down operating system where they've removed a lot of the default trust, you're going to need to know how to add trust. Now, what not to do, don't add trust for a self-signed certificate or something like that. But you will need to know how to add trust. Another way to troubleshoot the certificate issues and issues so for example in Java, there is a setting that you can set that says to start putting out debug input on SSL connections. And when you dig into that, if it starts saying that there's a certificate connection issue, sometimes it doesn't get very specific, which is true for most languages. You can start looking at things like this SSL test, which is a public site, and you can put, assuming your URL is available on the internet, you can put your URL on there. It'll go hit the URL and evaluate the certificate and make sure things like the certificate chain is correct. And the TLS encryption is good enough, or if it's weak, and there's certain languages that will reject weak TLS connections, which is a good thing. And again, OpenSSL. So, and I will say that I usually use OpenSSL primarily because things like SSL test, there's a way that you can add it to, like anybody can go to SSL test and see your previous test results, and if your previous test results say, hey, they had really weak encryption, you probably don't want to advertise that. And there's a little checkbox that if you forget to check, it's going to do that by default. So I usually try to use OpenSSL first, and I will say that it takes a little bit to get used to it. But the main command that you probably want to know is this command. And what this will do is it'll go out and it'll do pretty much what the SSL test will do, which is it'll go hit the endpoint, it'll pull down the SSL cert, and it'll warn you if there's any issues in the chain or the encryption or the reading of the certificate. Things it won't get into necessarily is if the encryption is weak and things like that, but it will tell you if there's specifically issues in the chain. So at least you can go and then hopefully talk to somebody that knows how to deploy certificates and show them this, and they can usually fix it. Something I will say, I could spend an entire day talking how to troubleshoot certificates. So I'm not going to do that, so we're just going to do the high-level, most common problems here. But what I will say for all of this stuff, in this case, Google is your friend. So for example, I did a quick search on Java key stores, and I immediately found a really quick thing that actually tells you correctly how to know how to install a certificate into a Java key store on different operating systems. Similarly, IE and browsers have their own trusts. Sometimes they default to the OS, sometimes not. And I found a quick article on how to do this for IE. What not to do, because unfortunately, like Stack Exchange, sometimes the answers that get voted up are because they're easy, not right. So if anybody tells you to remove the trust check, don't do it. Which when I was first trying to troubleshoot Java, it annoyed me because that was like the first result. And you'd go in and they'd say, oh, just go do this, and it shuts off the trust check. No, that's like the hack me option, and you don't want to do that. Okay, so the next thing is to understand your client errors. So in HTTP, these are your 4XX errors, right? They usually indicate something in the client application was wrong. It's not always true, but it's the best guess of the server that you did, the client application did something wrong. It's syntax, invalid parameters for queries, missing fields can come back this, so required fields that you didn't send. 401 and 403 specifically start getting into authorization and authentication. So 401 is you called something and you needed to authenticate. Double check, and the most commonly I will say when people actually ask us about this, it's because they thought they set the bearer token, but they didn't. So always double check your requests. So in a browser, you can open debug tools and see what's sent on your headers. Make sure it actually got sent. 403 is you did something that's not allowed. A lot of times, for example, your OAuth token doesn't have the right scope. So you tried to write a medication, but the scope wasn't granted in your authorization token. However, some things that you would consider like unauthorized access might come back as a 404, which seems a little strange. We'll get back into that a little bit. So 404s usually mean not found. You called the URL, something's wrong with the URL. You called in to read a patient that we don't know about. It doesn't actually exist in our database. So the first thing you do, check your URL, watch for typos, watch for spaces in the middle of the thing because you copy pasted. It also can mean not supported, and what do I mean by that? So in our server, a good example would be the open, our insecure endpoint versus our secure endpoint in our public sandbox. On our open endpoint, all reads are exposed. The conformance statement states all reads are exposed. On our secure endpoint, it has reads and writes. So our open endpoint really doesn't know anything about writes. So if you try to post to a URL in our open endpoint, it'll 404 it. It'll say, I don't know what you're trying to do. This resource post doesn't exist. And then, like I said, sometimes it's a security issue. So why do we return a 404? There is a lot of controversy about this, but generally, if you talk to somebody that's really like gung-ho on security, they will tell you that returning a 403 instead of a 404, so differing your response based on whether there's data versus there's not data is just helping a hacker. Your system obviously should be able to handle it either way, but why help somebody? And what do we mean by this? So let's say that I am in a browser and I've opened up development tools and I'm going to try some scripting. And I am a trusted user, so I do have access to the system, but I'm going to be a little bit nefarious. So I'm going to start typing in and seeing what I can do with the URL. Well, I'm going to start incrementing, like if there's an ID that looks like it might be incremented, I'm going to start trying to increment that. If you tell me 404 every time, I'm not going to know whether I found a correct ID that might exist somewhere. If you tell me 403, I know I found something and maybe I'll start digging in a little bit more. So why really help, right? So that's usually when you'll see a 404 possibly. And then if for some reason you really don't expect it, like this is actually something in your app, we can always help debug and figure out what is actually going on. So 406, probably the most common initial error that everybody sees. Not acceptable in the HTTP stack. It's the accept header. So in FHIR, you can also sneak in it under format, but in FHIR, DST2, it's application JSON for us, or application XML, or JSON plus FHIR, or XML plus FHIR. If you don't request anything, or you request something other than that, we'll 406 it, because we can't respond in the way that you asked us to respond. We don't know any other MIME types or how to respond with FHIR that way. Most commonly, people just forgot to set the accept header. We've seen people try to call servers that don't support XML or don't support JSON that way as well, and that you'll get 406 that way as well. And then, like I said, if you are just trying to debug, the format parameter can be added in FHIR to the end of the URL. So it's underscore format equals JSON, underscore format equals XML, and it does the same thing. 409s are conflicts. You're only going to see these on updates and patch. And what the heck does this mean? You're updating the wrong version. You probably got into a race condition with somebody else. So you read the document, you went to update it, somebody else updated it somewhere else. I'm not going to overwrite their changes, and so we're rejecting it to say that there was a conflict with whatever you were writing. Similarly, similar to the 406, 415 is the same thing except for you probably posted, and so your body type description wasn't acceptable. So you tried to send, for example, our server XML, and we don't support it. or you tried to send us text plain and we don't support it, or you forgot to set it and tell us what you were trying to do. And again, FHIR, it's the same thing, just set those. The underscore format parameter is hit and miss on posts. A lot of times it depends on the underlying implementation and if it combines the post query parameters with the post body. So I will say that the underscore format parameter is kind of hit and miss on this one, so I would actually use the content type header. And then 422. Once people actually start getting into standards and writing resources, you will probably see a 422 error in sandboxes, maybe not in some of the pure FHIR reference servers because they don't have to do this logic, but in servers that run in production. So what does a 422 mean? FHIR says it's impossible. What the heck does that mean? The body was fine. The server understood it. It was syntactically correct, but something else went wrong. In our server, the most common issue is when a value can't be interpreted. So for example, if you sent me an allergy to, I don't know, Himalayan cats or something like that using SNOMED, and I don't even know what that means in my system, or I can't map it so that I can write it in my system, I will 422 that because I don't want to accept data that I literally can't record to the database in the way that it will be interpreted. So Himalayan cats are probably not going to cause a medical interaction, but if it was a medication and I can't record that, I don't want there to be some free text thing that makes it look like we've got an allergy in our system, but not have alerts and clinical checking FHIR. That would be kind of dangerous. And most commonly, this is going to be mappings. So if you see this and if your application really needs to write this, this is one of those conversations you have. So for us, we try to, when we're validating apps, understand codings that they need and make sure that when we build the app, we build the requirements. If for some reason you were getting a 422, reach out to us and we'll make sure it gets mapped. In our sandbox, we don't map the world. It's pretty hard to do that, especially in a development domain that has some pretty ridiculous looking data. But for example, we have document rights and we have a very small subset of codes listed that are available in sandbox just for testing. We will always support more than that in production, but just like I said, you can just post or talk to the person that you're integrating with. All right, so server errors. Internal server error, obvious. These are not probably the app's problem. These are bugs in the server. So you should talk to somebody about these. So internal server error, something went wrong, right? The most descriptive error ever. 503, server unavailable. This is one of the few ones that can be a transient issue, right? Hopefully it doesn't happen often. If it does, please let somebody know. It means we've got a load problem probably. But for example, in our sandbox, every once in a while, we do some testing. And instead of doing something like blue-green, we'll just take it down and do things under the covers because it's our sandbox and we're not too worried about it. We usually announce that beforehand if we're going to do that. But we want to make sure, like, for example, that we get a 503, that it actually responds like we expect, that the system works. And it is our sandbox as well. And it's a better place to test than in production. But if you do see this a lot, again, whoever the FHIR server is, you post. I know Graham's server does this every once in a while because we get a lot of Zulip posts about it when his server goes down. And then for our server, we return a correlation or X request ID. So especially on those 500 errors, you probably won't have a clue what just happened. I wouldn't expect anybody to have a clue what just happened in our server. But if you give us, for our server, these request IDs, we can go track it down and log defects. So once you've hit the end, so you've done all this stuff, you're experts now on HTTP, right? In this 10-minute so far presentation. Knowing where to go for help is really, really important. And there's a lot of help out there, and knowing where to find the links is also very important. So for the FHIR specification, if you haven't already, please go get on Zulip. Go get on chat.fhir.org. Not only can you ask for help there, but it has amazingly good discussions about how the spec is interpreted and how things work. So it's also a really good resource just to see how other people are implementing the spec and how certain things were intended when it's a little fuzzy. There are also other places. There are just flat out listservs if you're really a fan of listservs. There's a couple things that are listed on the support page that are other places you can go for help, but I would say that the chat.fhir.org is one of the better places. For SMART, there is a Google group that they will answer questions, and that's monitored by the community as well as the people that drive the SMART specification. And then each vendor will have their own specific place. For Cerner, ours is a public Google group. So if you ever have questions, you can go out there and you can ask them. We also will notice when questions, for example, get posted out to SMART, and a lot of times we'll go answer on there and get people to come over to our side. And we also send people over to the other side. But definitely, if you ever need help from ours, it's a public Google group. You can also search and see what other people have asked similar questions. So this is a picture of ours. I will call out that I know a lot of people like to use Google groups like listservs, but it is nice to go out to the actual web page. We do call out a lot of warnings. While I have only had to ever ban one person from our Google group, I do it. And it is primarily when they repeatedly violate those big red things up there, because those are not good, right? I don't want the security or my patient privacy compromised because somebody doesn't know what not to do. We always warn ahead of time, and we try to get things off, but unfortunately Google groups send emails, so once it's out there, it's out there. And the only person I've had to ban, I think I had to warn them 4 times, and then I had to stop it because they were responding saying, okay, but not changing anything. All right, so that is kind of the basic of most of the issues we see with FHIR. OAuth. If you've never done OAuth 2, it can be a little confusing. Primarily around how the workflows work, and I would say that OAuth 2 is closer to a framework than a specification in that it sets the guidelines and the guardrails, but then you have to actually implement it. So for example, SMART is a profile on OAuth 2, and it says which specific aspects of that apply, and it's not the entire specification. So in our server, and I think by specification, there are some errors in OAuth that will display to the user. These errors that display to the user are errors where we cannot validate trust with the application. So for example, we don't know that the application is trusted. And if we don't think the application is trusted, we're not going to send an error or the user back to that app because we don't know what that app is going to try to do. So these will display to the user and say, something is wrong. You need to contact either support for the application, and here's some more information that you can supply. The other thing that OAuth allows is an error URI. These are the ones we will send back to the applications, and it's really useful. There's some really yuck-looking codes that can come back from that, but the error URI, you can literally load that in the browser, and it'll give you a textual description of what we think went wrong. And again, in our server, we return a correlation ID. So if you can't figure it out, and I will say some of the codes are very fuzzy, we can go and track down what happened as long as you can give us the correlation ID. We also have documentation that has, and there's some other places, but on our documentation we have actual examples of each type of OAuth request, like actual bodies, examples of the parameters that are sent. The first thing to do with OAuth is, I would say, go compare it to an example and see if you're missing a parameter or not escaping something or sending things in the post URL instead of the post body as an example. But the most common one is scopes. So people are like, well, I tried to call the resource. It told me I couldn't call it, but I swear I requested the scope. Double check. that you actually requested the scope, and then specifically in OAuth, part of the specification says you can request the scopes you want, the user can choose to limit it, and so the OAuth server returns the set of scopes it actually granted. As an application, validate that. That is the one thing that is super easy that I have not seen very many applications do. It makes it so that your application can gracefully degrade functionality if it can. So for example, if you think about on your Apple or your Android phones, they let you say what permissions applications can have. Most of those permissions you can uncheck and the app might still mostly work. If your app can do that, do it, right? If it's core to your functionality, you can error when it comes back to you and at least let them know what happened. So here's an example of what it looks like in our server when the user gets displayed, or if you load that error URI. This is the correlation ID I'm talking about. If you send that to us and you can't figure out what happened, we can let you know. But the code will also be listed here. And so in this case, it's pretty direct about what it said is wrong. Part of OAuth is you have to send in the request, the redirect URL. We check to make sure it matches what's registered so we don't redirect to some nefarious person. And so whatever you sent, it didn't match what you registered. And so that one's one to go double check what you have registered versus what you sent. And trailing slashes matter. Like per spec, it has to match. So keep that in mind. Common OAuth mistakes. There is a parameter in the OAuth spec called state. This state parameter is so you don't get hacked. So it's important to understand what it is and use it correctly. What it is it's supposed to be a one-time use, not predictable value that you send to the OAuth server and that the OAuth server will send back to you when it redirects. And what you're doing is you're making sure that you're not getting bad actors that are trying to send you a redirect to send you somewhere else or to send you invalid code or to get into your app. This makes sure that you validate that the redirect you're getting is coming from the server you expect and for a request that you understand. A lot of people that use this also use this as a way to hook up with the right session if it's browser-based. Just make sure it's not predictable, because if it's predictable, that kind of destroys the point. I would call most of these the don't get hacked guidelines. A lot of these are talked about in the OAuth. There's a security RFC that goes along with OAuth 2 that talks about how to prevent security attack vectors. So one of them is to whitelist the FHIR server. Why would you do that? Why would you whitelist the FHIR server in Smart, right? You get past that FHIR URL, you follow discovery. So what happens if you follow that FHIR URL? It gives you an OAuth server. You go and send any secrets you have to this OAuth server. You call that FHIR server. What if the OAuth server wasn't one that you should have sent secrets to? Who did you send your secrets to, right? Now they can go and try to use it. Probably not a good idea. Another reason you whitelist the FHIR server is there's a much more interesting attack, which is I have seen people whitelist the OAuth servers before because they recognize they shouldn't send secrets to bad actors. A lot of people miss this one. And what will happen in this attack is somebody will set up a FHIR server that uses the right OAuth server and its metadata, because we're discovering things, right? And what you'll do is you're like, cool, it's a good OAuth server. I follow it, I'll send it my secrets. I'll get the token. I'm going to go call the FHIR server and pass it my bearer token. If you just pass somebody that's trying to act as an in-between between a trusted FHIR server and a real FHIR server, you just handed something that allows them to go get PHI, PII, acting as your application. So that is why you want to whitelist a FHIR server. You don't want somebody to try to hack your application and use your authentication credentials, essentially, to get data and to cause a breach. If you are going to use the OAuth 2 mechanism to secure your application, so you're going to trust the user identity and use that for any kind of authorization or license validation, validate the signature on the ID token. Make sure it's, again, you're looking for your trusted sources if you're using anything for any kind of permissions or authentication. There is documentation on how to do this on our OAuth page. It links out and shows you what to do, but it's part of the OpenID specification on how to do this. And then finally, protect your secrets. If you sign up as a B2B app, which means all you have is your app ID and your secret, or a confidential app, don't go put the secret in a browser, right? If you're a JavaScript only application, it's not appropriate to have a secret. There's a profile on OAuth 2. It's your public application, because that just means you just gave your secret to somebody. Don't check it in code, right? It's not a good thing. Make sure you protect it all the way through. Even it's a bad idea, obviously, to send your secret to a browser as well, because I can easily crack open developer tools and see that. So if you have native apps, most operating systems have a secure store that you can use, so you can read up on documentation. All right, so for Smart, the biggest thing is know your browser, because most of the debugging for Smart is going to be using your browser's documentation. We won't have a lot of time to go through this. We're running out of time. For us, we documented a lot of FAQs on our Smart servers. This is a really good place. It doesn't just cover our Cerner server. It covers some things that would apply to a lot of places. Some of the most common ones, though, and if you're familiar with web development, it's browsers. IE versus Chrome versus this version of IE versus that version of IE. So know your development tools, know how to open those tools. Ask especially if you're getting embedded into an EHR, know your browser versions, know what their minimum support is. So for example, if you look at statistics, it's kind of sad how many people are still on IE 9. But unfortunately, hospitals tend to move a little bit slower in tech. And so I believe even our minimum that we have forced clients and all the applications to validate against so far is 10, which is still not the full edge browser for IE, for example. So we tell developers that you will probably have to run against IE 10. And then we bump that up as we get all of the applications that run in those browsers validated. You as an application developer probably want to publish your maximums, because you'll have issues as well. Most people you can't be forward compatible with everything. It's just the way it works. So also be cognizant of what you're coded for. And then know your resolution in real estate, and most specifically, be responsive. We do have our resolution in real estate published, but it's good to be a responsive app. That way you don't have to worry quite as much about all the very specific things. So don't hard code pixels and things like that in there. And then especially for IE, because it likes to be in compatibility mode, the XUA compatible header is something that you have to set on every single page to keep IE from going down to compatibility mode and IE 9 sometimes. It does have to be on every single page, right? This is probably the most common first miss we have when apps start to see weird JavaScript errors in rendering behavior. It's that IE decided it's going to go to IE 9 and not the Edge browser. This is specifically embedded browsers. Embedded browsers are used by most of the vendors I know, because they've got native apps and they want something to show up in that native app just like it's a native experience. And to do this, Microsoft and everybody provides an embedded browser control. They don't work well. So they come with limitations, like running in compatibility mode by default. More scary, session storage is not partitioned by tab. It causes bad things. When we were in our beta and doing demos at the very, very, very first HIMSS with like kind of put together code to demo capabilities for Smart, we realized that we would change patients, and then we'd look at tabs that we had in different tabs, and suddenly it was the other patient's data. And it's because by default, the FHIR client is using session storage. The FHIR JavaScript client was using session storage under the covers. And as you switched, it switched the session. Not something you want to have in a clinical setting. Bad things happen. So keep that in mind. Avoid session storage if you can. Cookies aren't shared with pop-ups. So if you have a scenario in your app in an embedded browser that pops open in another window, the cookies aren't going to go. So if you're using cookies to help secure that session, it's not going to work. And then more helpfully, we've open sourced an embedded browser control that you can include in your application. It's actually not just used by Cerner. It's not Cerner specific. It's used on many of the apps that run in embedded browsers and different vendors. This will help you, and there's documentation on there about what it does, but it helps keep the session storage and the cookies in a more secure place. And then how much do I have now? Nobody? I think I have like 2 minutes. So I'm not going to go through all of these, but I will say that there's a bunch of errors that I would call the errors that weren't. Most commonly, this is going to be, I didn't get data, but I expected it. Again, permissions. Do you have access to read it? And those kinds of things. Did you filter it out? Did you query by status and just nothing matched, right? That can be okay. And data that's not mapped, there can be missing data. It's very similar. I see it, but I don't see everything I expect. Again, permissions and security. So smart apps, the user's permissions are enforced, and not all users have capabilities to see all meds. Not all users have capabilities to see sensitive lab results. And especially, there's regulations, not all capabilities in the US have, there's a legal law in the US, for example, that says psychiatric data is protected, and many users won't have access to data that comes out of a psychiatric facility. So those are things, and then sometimes it's not mapped. And then bad data, there's no codes, mapping. We fall back to returning free text to give you data, but sometimes it's not codified. Fields are empty, it just may not be set. But if it's a required field, that would be a problem. And then data is returned, but not as expected. As much as we want super clean data, it's not always there. However, if something is really unexpected and you look at how it's viewed outside of the application and it looks different, that's definitely a time to engage. A lot of these you're going to have to engage the vendor to troubleshoot because it's going to be hard to understand. So I already talked about that. So your stuff isn't mapped. I don't have a lot of time for questions. In fact, I think I have 0 time. But if you have questions, please come up and talk to me. I'll be here, and then I'm usually sitting out at the EHR table. The other thing I'm going to mention is that we usually actually run something like this as a lab. If you want to go and learn how to do troubleshooting and actually do some troubleshooting real time, there are exercises under the troubleshooting header out on this URL that run through some scenarios to try and to see if you can figure out how to do it. And then I believe on that wiki it links to slides that actually have the answers and why. Okay, so again, if you have any questions with that, let me know. All right, thank you.